So here's the list of formulas. Where did we get it? Let's go back. You go to EVI, UIHV, go to classwork, and you go to CSEC math information, and you go to CSEC list of formulas, and here they are. This is the formula, people, that you are going to get. Let's just read it. Volume of prism, V is equal to AH, where A is the area of the cross-section and H is the perpendicular line. Volume of cylinder, V is equal to pi r squared H, where R is the radius of the base and H is the perpendicular height. Volume of a right pyramid, V is equal to third AH, where A is the area of the third of the base and H is the perpendicular height. Circumference of a circle, C is equal to 2 pi r, where R is the radius of the circle. Arc length, S is equal to theta over 360 times 2 pi r, where theta is the angle subtended by the arc measured in degrees. Area of a circle is equal to pi r squared, where r is the radius of the circle. Area of a sector A is equal to theta over 360 times pi r squared, where theta is the angle of the sector measured in degrees. Area of a trapezium A is equal to half times A plus BH, where A and B are the lengths of the parallel side, and H is a perpendicular distance between the parallel sides. Roots of the quadratic equations. If ax squared plus bx plus c is equal to 0, then x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. Trigonometrical ratios. Sine theta is equal to opposite side over hypotenuse. Cosine of theta, adjacent side over hypotenuse. Tan theta, opposite side over adjacent side. Bear in mind the hypotenuse is always diagonally away from the box. The box is in 90 degrees. You can look at the box as pointing to the hypotenuse. Now, if this is the angle theta, this side is opposite to theta. If this is theta, this side is adjacent to theta. So it's because if this angle we are dealing with, this side is the opposite. Please bear that in mind. If theta was over there, then this side would be adjacent. But because theta is right across, then this side is opposite to theta. This side is adjacent to theta. So it's because theta is there, this side is the opposite to theta. But if theta was over there, here, this side would be adjacent to theta. So remember that. Area of triangle. Area of a triangle is half base times height, where base is the length of the, where b is the length of the base and h is the perpendicular height. Area of ABC is equal to half ABC. A is AB sine C. So that's another formula for area of a triangle. So there are three formulas for area of triangles. Half base times height, which is very popular, and half AB sine C. C is the angle between AB. And area of another formula for area of a triangle ABC is equal to the square root of S, open bracket, S minus A, S minus B, S minus C. That one is not very popular, but it's available, where S is A plus B plus C over 2. Sine rule. This is the triangle for the sine rule, which is not a right angle triangle. We can call it oblique because it has no 90 degrees. This 90 degrees is the perpendicular height. So the sides are A, B, and C. Smaller case A, B, and C. And the angles are uppercase. So the small b is opposite to capital B. Small a is opposite to capital A. Small c is opposite to capital C. So that's the rule for the oblique triangle. So A over sine capital A is equal to B over sine capital B is equal to C, side C over sine capital C. That's the sine rule. And A squared is equal to B squared plus C squared minus 2BC cosine A. That is the cosine rule. So here you have the list of formulas. That is what CXC is going to give us in the exam. So we move into module 11. Let's click on module 11, depreciation value. And here it is. Let's take a snapshot of it. Number 11, depreciation value. Calculate the depreciated value of a commodity. Find its final value or find its future value. Okay, example, Mr. Joseph bought a car for $50,000. The value depreciated by 10%. Depreciate means it reduced in value by 10% for wear and tear and so forth. What is the future value? Now you have the common approach, which most of us, if not all of us, know. You multiply, you take the percentage off, and then you subtract. But you have the flexible approach, whereby you must start with 100%. So we're going to do this using the flexible approach. So start writing. The first thing you do, you write down 100%. And because it's a depreciation, when it was appreciation, you add. Okay. See where we added, because appreciation, you add. But once it's depreciation, you have to subtract because it reduced in value. So you subtract the percentage, which is 10%. So you see 100%, subtract 10%, and that will give us 90%. 90% is the same as 90 divided by 100, because that line and two circles just transform it to 100 symbol, and you divide by 100, you get in 0.9. And because we find the future value, we multiply. Because we find the future value, we multiply 0.9 to 50,000. And that should give us the future value, which is reduced, which is 45, from 50,000 to 45,000. A flexible approach. Always begin with 100%, because it's depreciation, we subtract the percentage, then we convert it to a decimal. And because we find the future value, we multiply.